Hi everyone, welcome to Math. Today we are going to study chapter 6 triangles, exercise 6.2, question 5. In figure, DE is parallel to OQ and DF is parallel to OR. Show that EF is parallel to QR. So here the figure is given to us and then parallel lines are given to us. We have to show the other parallel lines are parallel. So before explaining this, let me explain to you the introduction for exercise 6.2 what I have told you. Two theorem we studied, basic proportionality theorem and the converse of it. So both I'll revise once again. Then it will be easy for you to understand. So what the basic proportionality theorem says that if there is a triangle ABC, okay, if there is a triangle ABC and then we have a one of this side, okay, we take base. For base, if we draw a parallel line EF, okay, so if it is told to us that BC is parallel to EF, okay, if these two lines are parallel, then the basic proportionality theorem says that if these lines are parallel, okay, this is given. If the lines are parallel, if these lines are parallel, then the ratio that is formed both the side will be equal. So that means AE upon EB. EB will be equal to AF upon FC. So this is what the basic proportionality theorem says. Okay, this is basic proportionality theorem. So when the line is parallel, then the ratios are equal. Now converse of it, just opposite. Opposite converse is that if the ratios are equal, then the lines are parallel. Just the opposite of it. So what is given? BPT says that if the lines are parallel, then the ratios are equal. But converse of it says if the ratios are equal, then the lines are parallel. So this is what we have to prove here. Okay. So let's see first. First, what is given to us? It is given to us that DE is parallel to OQ. DE. Where is DE? So DE is here and OQ. This is OQ. These two lines are parallel. So these two lines. DE. DE and OQ. Okay. So if these two lines are parallel, then this should be a triangle. PQO will be forming a triangle because two lines are parallel means then it becomes that triangle, right? So if these two lines are parallel means this becomes a triangle. So this is our triangle. PQO forms the triangle. So let's write down that. So in triangle PQO, we have, that is, DE is parallel to OQ. DE is parallel to OQ. So by basic proportionality theorem, if this is parallel, that means the ratios are equal by BPT theorem. So PE upon EQ. Okay, PE upon EQ will be equal to PD upon DO. Okay, so this we keep it as equation 1. Now the next one. Next, what is given to us? DF is parallel to OR. DF is where? Here. DF is parallel to OR. So this two. So DF parallel to OR. So if these two are parallel, then this becomes a triangle. Okay. So then can we say that POR is a triangle in that these two are parallel means the ratios are equal. So that only we have to write down. So in triangle POR, we have DF parallel to OR. So if these two are parallel, then the ratios will be equal. So by BPT, we can say that PD upon DO. Let's take the other side, okay, because we have to prove finally these two are parallel, because PD upon DO, this PD upon DO, let's bring it one side. So here we have written one side, this side. Here we have written first this side upon this side, no, this side first, then second we wrote right side this. So same way, let us take, this is left side and this is a right side. So let's take PF, okay, PF upon FR will be equal to PD upon DO. Why? Because so that it comes same direction, otherwise it will become opposite. So first we wrote outside, this side we wrote first P upon EQ, then PD upon O we wrote. So same way for this side we will take the outside first. So PF upon FR upon PD upon DO, so that we get to the same side this, okay. So this becomes equation 2. So now you see P upon EQ equal to PD upon DO. Here PF upon FR equal to PD upon DO. So that means PD upon DO, both right side. If both are same, that means the left side will be equal. So PD upon DO is equal to this also, and PD upon DO is equal to this also. So if this is equal to this, then these two will be equal to each other. So we'll write from equation 1 and 2, we can write that PE upon EQ will be equal to PF upon FR. Okay, so let's see now what is PE upon EQ. PE upon EQ, so this yellow color side, and PF upon FR. PF upon FR is the green color side. So that means this side and this side, the ratio is equal. That means of this triangle, this line will be parallel. So that's what I have said in the converse of basic proportionality theorem, that if the ratios are equal, then the lines will be parallel. So here the ratios are equal, you see. So we have proved this, the ratios are equal. So if these two ratios are equal, then the lines will be parallel. So EF is parallel to QR. So that's what we have to prove here, you see. These two, we got equation 1, equation 2. So show that EF is parallel to QR. So we have to show EF is parallel to QR. So we have showed that, see, these two are equal means then this line will be parallel to each other. So therefore by converse of BPT. Converse of BPT is when the ratios are equal means lines will be parallel. Converse of BPT, we have EF is parallel to QR. That's it. Thank you and God bless you.